So last time when we went over the graphing, we went over graphs of distance versus time, where you had distance over here and time down here, and then the slope of that line gave you the velocity. So m equals velocity. What we're going to do today is we're going to talk about situations where you have speed or velocity versus time, and that's going to do something very different for us in terms of meaning. So if we take that same line that's got pretty much a steady slope, especially if I drew it well, what this tells us is that for each unit of time, this has gone up the same amount, which means now the slope equals acceleration, because now we're not talking about a change in how much distance there has been over time, but now we're talking about an increase in the amount of speed that there is over time. So that's the definition of acceleration. Acceleration is when you have a change in velocity over time. So in this case, we have a situation where it's straight line up, which tells you that you have constant acceleration. The acceleration is not changing because the slope of that line is not changing. If we had, let's try to get fancy here. I have a new stylus. I hope you guys appreciate the fact that I'm getting better at this. If we have this red line down here, well, that represents a scenario where the change in speed over time is not as big. So therefore the acceleration is not as big. If we have another scenario there where we have the green line, the change in speed over the same amount of time has been larger, therefore the acceleration is larger. Hopefully that makes sense to everyone. I'll go through and I'll probably post some Khan Academy videos for some of this stuff as well. So that just to give you kind of the simple explanation here. So let's take a look at some a little bit more complicated scenarios. So we'll say we have a situation where we have that, and then that. So I'll extend the axis over here a little bit. And this is velocity versus time. And we'll say this is point A, B, C, and D. Okay, so now we can start to talk about these things in terms of, well, what do we know about line A to B? So, well, it looks straight and it has a positive slope. That means that the slope there is an acceleration. And what we know from this is that A to B has a greater acceleration than at any other point in here. We don't know exactly what it is because we don't have numbers on here, but we know that A to B has positive acceleration. Okay, from B to C, what we can see is that the line is flat. Now, a flat line on a velocity versus time graph does not tell you that there's no motion like it did on the other one. Now this is telling us that the velocity stays the same. So here you have constant velocity. So it's still moving. It hasn't stopped, but the movement has tapered off. It is moving at the same velocity. Now from C to D, what this tells us is that as time goes forward, the velocity goes down. So we have negative slope. So that equals negative acceleration. So hopefully you guys can see that. And eventually what you see is the velocity ends up getting back down to 0. So here, velocity equals 0. Hopefully everybody kind of can see what's going on with that. And another thing that we can say is that the acceleration on this part was higher than the slowing down on this part, because that slope is less than the slope from A to B. That means it's slowed down slower than it's sped up. Okay. One other thing that I want to just point out is if we same axes and we have velocity versus time again, well, what happens if we have a curve now? So this would tell us that as time increases, that the change in velocity gets faster. So now we do not have a constant acceleration. Now we have a changing acceleration, and that acceleration is actually speeding up. Whereas if we did that on a speed versus time graph, if we had the same thing, all right, looking at these two lines, they're basically the same basic form and function. But when you have speed versus time as opposed to velocity, what it basically means is that the speed versus time shows acceleration if it's curved up, whereas with the velocity versus time it shows increasing acceleration. So hopefully you can kind of see what the different graphs mean. I like to always think about it in terms of as time increases, as time goes by, what happens to the thing on the y-axis. Same thing here. As time increases, okay, what is happening to the velocity? So you're going to have some assignments where you're going to deal with some things like this. Hopefully you do well. If you don't, come see me during my office hours. Okay, have a good day, guys.